The central limit theorem for sample proportions. Why do we use it? There's three reasons we would use this theorem: to describe the shape, center, and spread of a sampling distribution, to find probabilities involving sample proportions, and to determine if a sample proportion should be considered unusual. So what does the theorem say? It says that if certain conditions are met, most importantly, if the sample size is large enough, then the shape of the sampling distribution will be approximately normal, the center of the sampling distribution will be the same as the population proportion, and the spread of the sampling distribution, which is called the standard error, can be found using this formula. The standard error is equal to the square root of p, the population proportion, times 1 minus p divided by n. Now, the conditions for using the central limit theorem, there are three. The sample has to be random and independent. In other words, we're working with good data. The sample size is large, and the population is large, at least 10 times larger than the sample. Now, the reason number 2 is bolded is because when you use the central limit theorem in our class, I'm going to always assume that we're working with good data. I'm going to always assume that the population was large. Otherwise, you should just go out and measure the entire population. So the only condition that you have to show that you checked was that the sample was large enough. And the way you show that the sample was large enough is showing that n times p and n times 1 minus p are both greater than or equal to 10. If these conditions are satisfied, then you can use the central limit theorem to do these three types of problems. So let me do an example of one of each kind. According to this website, 59% of vegetarians are women. Suppose a random sample of 500 vegetarians is taken. Describe the sampling distribution for samples of size 500 drawn from the population. This means discuss the shape, center, and spread of the sampling distribution. Begin by showing that we can apply the central limit theorem. So again, the only condition that you have to check is that your sample size was large enough. So we're going to start by showing that n times p and n times 1 minus p are both greater than 10. So n is our sample size, 500. P is the population proportion, which is given in the problem, 0.59. And n times 1 minus p would be 500 times 0.41. And you can either use a calculator or your good number sense, but these values are both greater than 10, so we can go ahead and do this problem. So what does the central limit theorem say? It says that the sample's proportions will vary from sample to sample, but the shape of the sample proportion, the sampling distribution of them, will look like this. The center will be at the population proportion, which is 0.59, and the spread, the standard deviation of this distribution, which is called the standard error, can be found by doing this formula. The square root of 0.59 times 0.41, that's p times n 1 minus p, divided by n, 500. And if you do that, you're going to get 0.02. So the shape is normal, the center is 0.59, and the spread, the standard error, is 0.02. What is the approximate probability that the proportion of females in our sample will be more than 63%? That's an example of finding probabilities involving sample proportions. So we can use the picture that we developed in the first part of the problem to answer this question. I know the distribution looks like this. We know the spread is equal to 0.02. And what we're being asked to do is to find this probability, the probability that a sample proportion is greater than 63%. Well, that's finding the area under a normal curve. And you know how to do that using StatCrunch, because that's what we learned how to do in Chapter 6, find areas under a normal curve. So you're going to go to your normal calculator. You know that the mean is 0.59. The standard deviation of this curve, the spread of this curve, is equal to 0.02, and you're looking for the probability that x is greater than or equal to 0.63. So you would just put this information into the normal calculator and get your answer. The third way you can use the central limit theorem is to determine if a sample proportion should be considered unusual. So this last question, complete this sentence. It would be unusual if we found a sample proportion that was greater than blank. Again, we'll use our picture. So we have a normal distribution centered at 0.59, and we know the spread, the standard error, is equal to 0.02. Remember that if you go out 2 standard deviations from your mean in either direction, these values here would be considered unusually high, and the values to the left would be considered unusually low. So the question is, what is this number? Well, it would be 0.59 plus 2 standard errors. And if you do that calculation, you're going to get 0.63. So if we found a sample proportion greater than 0.63, or 63%, it would be considered unusual.